So this is 152, and I'll have the midterm grades calculated soon, probably within the next week. There's no midterm exam. I'll just take the quizzes and projects up to that point and make a grade out of that. And we're down to chapter 10. And tonight, after that, I'll demonstrate the first couple of Velociraptor projects, or maybe just the first one, but we'll get Velociraptor going, which is what we'll occupy most of the rest of the course. We're using Velociraptor to do things. All right, so today we're talking about enterprise services, the kind of software that you're going to see on enterprise networks. So one of the things that's going to happen to you, of course, is infrastructure. So DHCP is what's used by all portable devices and many wired devices too. When you boot up your machine, it does not have a hardware configured IP address. It asks a server to tell you what IP address to use. And this is very useful because then you can upgrade your network, add more devices, segment your network and such, and you just adjust the server to hand out the right addresses. Back when people used manual addressing, it was very common that your address was wrong and you couldn't move your computer from one network to the next. And it was very annoying. So this is what almost everybody uses. It has a second effect, which is that your IP address might be different when you boot up again tomorrow. Now, typically, you keep getting the same IP address, but it's possible that all the IP addresses were used and it reassigned that address to somebody else. So it makes it a little difficult to analyze network traffic, where you see an IP address that if you don't have DHCP logs, you don't really know what machine that was. It could have been a different machine. So that's an issue. All right. So you get a DHCP lease each time you boot up or reconnect to the network, and so you need those logs if you want to be able to get down to something like the MAC address, which will really uniquely specify which device was connected. So you can search in your logs by a date to find out which system had the address when something happened, like a malware alert or some other indicator of compromise, and you can search all dates for a MAC address and get a list of all the IP addresses that machine had, and then if that machine is in fact causing trouble, you can perhaps connect together all the trouble it's causing, because unfortunately, it won't all be from just one IP address. You'll have to correlate it. All right, so the logs are in there. Microsoft, you can use a Microsoft DHCP server. And if you do that, it's just part of Windows Server, and it gives you a plain, common, delimited text file with just the information here, like the time and date, MAC address and IP address, and a few other things, a nice simple log. Time is local time, which is annoying, and what's even more annoying is it only retains logs for 1 week by default, and you definitely want to keep that longer for instant response. So you want to adjust that and make it longer. ISC DHCP is very common. That's the open source Linux version. It logs on a syslog local 7. Which is just a network logging system. All right. And you can see the DHCP log here, and you see it's got a DHCP acknowledgement was sent here to that address, and here's an inform sent, so it logs each of those. There's like 4 messages in DHCP: request, inform, acknowledgement, something like that. So it logs each message here, but the information you need is in there. Yeah, here you go. Discover, offer, request, and acknowledgement. Those are the 4 different kinds of things. DORA. Well, I don't know what that is. Anyway, anyway. All right. Then there's DNS, which resolves alphabetical domain names to numerical IP addresses. And so your DNS logs will show every domain visited and the IP that visited it, which is extremely useful. You know what everybody's doing on your network, and that's important. You can, some malicious servers change their IP addresses frequently while still keeping the same domain name. That's one of the many ways to conceal which server you're actually talking to when you're having something like a command and control server. Discover, offer, request, acknowledge. Oh, okay, good, thank you. The mnemonics remember DHCP, good. All right. So Bind is the famous original DNS server. It's what many people use. Berkeley Internet name, I think daemon, it's a domain anyway. It doesn't have logging by default. You have to turn it on. And when you do, you'll see logs like this. A query was made to find this, this domain. This was the answer, and that was the client that requested it. Microsoft has a DNS server too, and again, logging is off by default. And if you restart it, it erases the old log. But you can turn on logging, and you can specify all the things it's going to log, and it'll make this text-only event here recording the same kind of information. So it's not complicated, but that's what it looks like. You can also do it at the network level if you're still using unencrypted DNS, which most people still are. There is a new system called DOE, DNS over HTTPS, where all the DNS is carried through an encrypted HTTPS packet. And if you're doing that, you can no longer sniff the network to monitor DNS. But most people are still using unencrypted UDP port 53, and therefore you can just capture it with any packet capture utility like TCP dump. And in some of these classes, I show you how to write Python scripts to make these logs. You can just log them right there, log them off the wire or save a PCAP file, and you can see what people are doing on your network. Of course, if what you ought to do at a company is force everybody to use your DNS server, block all the others, so you can control what happens, and then you just log it at the server. Then you know what's happening. Anyway, let's take a look at a Kahoot. Well, let me change it. There it goes. Is DNSSEC the same as DNS over HTTPS? No, it's not. DNSSEC is, let me turn down this music and answer this question. DNSSEC is a security protocol which does not protect the client at all. It just prevents the server from being poisoned by a particular attack from 2008. It turns out to be, and it's very slowly being deployed. It doesn't do anything you can tell. It just means that the server is less likely to contain false data when you do reach it. DOE, DNS over HTTPS, protects your privacy as an individual client, encrypting the traffic on your local network. So it has more direct effect in preserving your privacy. DNSSEC is really just an integrity mechanism for the server's data. All right, and we lost one. Guess I'll wait a few seconds to see if they come back. All right, we'll carry on. All right, so which one causes your IP address to change? Yep, that's Dhcp, of course. All right. All right, which one goes on UDP 68? That's Dhcp, and I think it goes on UDP 69 also, but I could be wrong about that. That might be TFTP. Anyway. All right, which one only retains logs for a week? That's Microsoft, Dhcp. Which one comes from Berkeley? All right, Bind, famous DNS server. All right. All I don't know who that is. I don't know who that is. I don't know who that is, but I don't think they care. All right. Right into the front, and it doesn't appear. Oh, there it is. It's just in front of me. I didn't recognize it. Okay. All right. So here's a couple of softwares you might find running on networks. There are a lot more available, but here's a couple that you might see on Landesk and Altiris. These are ways to keep track of what you have on your network. There's a lot of these. Try to find what hardware and software is running on your network for things like license monitoring to make sure if you bought 50 copies of Photoshop, you're only running 50 copies of Photoshop, and so on. This tracks the execution of every application so you can make sure you're staying within the limits of your license. And of course, that's very handy for instant response. It's a log like the log in the prefetch folder and other places like the shell bags that help you see what's been happening on that machine. So now one thing attackers do is they will often copy a suite of hacking tools like password hash numbers and other things. They'll run it and then delete it. And this will be recorded in the monitor, in the registry. Even if they delete the binary, the record that that thing was launched is in there. So you'll have a registry key here in the Landesk Management Suite folder. And in there, each application will have a separate key showing when it was first started, how many times it was run, the last time it was run, who the user is, and so on. So really quite handy. So if you go in there, there's different tools you can use for it. Redripper is one of the tools you can use on exported registry hives to read this data. And so low total runs, for example, if there's something you use at your company, they probably use it every day, so it'll run hundreds of times. Something that's only run once is kind of suspicious. That's not normal. If it's running from the same place, like in the recycle bin or something like that, that also would be a clue that it's not a normal thing, not running from the program files folder where normal things would run from. You can look for things, you can also look for built-in utilities that are rarely used. Like these are things that live on the land attackers will use, net, at, cmd, and all this jazz. If normal workers don't use the command line Microsoft utilities, they use applications like Microsoft Word and stuff. So using these things might indicate an attacker using Microsoft tools to do lateral movement on your network. The current user might show suspicious usernames if they've somehow got in with an unusual account other than the normal user of that machine. User accounts that haven't been used much are also suspicious. Accounts that shouldn't normally be there or with elevated privileges are all clues that something funny is going on. Executables that have been deleted. Now, an installer, you download it, you install it, and then you delete the installer, so that's normal. But other tools that are run and then delete, that is not normal, and that's suspicious. Of course, it might be that somebody downloaded something, tried it, and didn't like it, but you know, that's a suspicious thing that an attacker might do. So, Symantec's Altiris suite is another way to do application metering. This will record the execution history of applications, and you can control it. All right. And so you have a plain text file with the software and the manufacturer, which I assume is the digital signature. It should be. And that would tell you if it's signed software. Somehow a lot of hacking tools are not signed and don't have a manufacturer. And date of first and last execution, run count, total run time. Those are all useful clues. So you look for executables without version information. Look for file size. Malware is typically small, simple command line tool, not like a big commercial tool. And you might see the same item with the same size but different names on many machines. That's a common trick. They just rename things, but it's really the same file. And then, of course, antivirus, which is what most people think of first to detect things. And it's not enormously effective. It's pretty easy to modify things to get past antivirus, but often people do use normal malware, and it just sets off your antivirus. And when that happens, of course, that's very handy because you already have a defense. So if you're running one of the enterprise antivirus suites, I say you cannot count on them to detect all the malicious things, but if they do detect something, then they have nice standard things to do. So you can configure them to quarantine files instead of deleting them, which you definitely want to do because you want to have a sample of it to examine. They put it somewhere where it can no longer execute, typically by doing something like XORing it with a constant to scramble the bits so it won't run. And attackers often use password-protected archive files because, that's a simple way to get them fast antivirus. If I password protect a zip file, then the antivirus can't open it, and all the bytes are scrambled, so it's not going to match any signatures. So the zip file itself will not trigger an antivirus alert. The problem is, of course, if I unzip it and what's in there is standard malware, then it would likely trigger an alert. But maybe I can get away with doing that in memory or something. Anyway, it might, however, log errors telling you that there's a zip file I can't open here, and that itself is a suspicious event. All right, so semantic endpoint protection has logs, and it also puts events into Microsoft event logs. And it had this strange pattern of timestamps. This is semantic, Norton, you know. It had some weird proprietary technique with 6 bytes with month and year and day in a weird format. You'd have some weird nonsense like this, like 20 is 2002. The hexadecimal number of years to add to 1970 and so on, sort of like a imitation of the Unix timestamp. All right, and it had quarantine files. It would store 2 files, first metadata and then an encoded copy of the original file. And it does it by XORing. The old version just XORed with a constant thing, byte of 5A, which is just a way to scramble it so it won't run. Newer versions do something more complicated, and they give you a tool that can extract the files, but you have to run it on the system that quarantined the file, which is pretty rude. All right, and so there's ways, if you want to do this, you have to boot up a forensic image of the infected system, or there's a Python script that's supposed to reconstruct it, but apparently it isn't terribly reliable. So that's a thing to know. Then there's Mcafee. Remember John Mcafee hated the company that he started. He left and said it was the worst stuff in the world and stuff before he died. One of his wild man activities was to badmouth the old Mcafee software that made all his money. Anyway, people use it. So Mcafee has its own logs. It's got a log of the date and time log applications that attempt to terminate Mcafee, buffer overflow protection, and other things on here like scheduled scans and virus-enough updates. So it stores all this information about the action of the antivirus product. And so the most useful is the on-access scan and on-demand scan. This will show your files that were detected and quarantined or deleted. And it also puts them in the Microsoft event log. So it stores the quarantine files with a bup extension with details, and then file O is the actual quarantine file, which again is just XORed with a constant and compressed. So you can extract it with 7-zip, and that's good. They don't do anything screwy, so it wouldn't be that difficult to extract the original file from here, but it is modified so that nobody can run it by just double-clicking on it, which is the point. And so here's metadata for the pwdump hacking tool. This is what it will install, pwcrack, pwdump.a, so it's detected as a password cracking utility, and so it's got a creation date and all that jazz, and here's the original name telling you where it was, so, you know, pretty easy to read. And then Trend Micro is another antivirus. So it stores the logs locally in plain text with the, you can see the path to the file and the name of it. And I guess this is like date 2013-0501, and that's probably time and day. So again, you got a lot of what you need there. And it encodes them, and there's a tool, VS Encode, to decode them, just like they all after you quarantine it. All right, so they all work about the same. And let's try another Kahoot, 10B. And as you know, the whole point of this course is people used to really trust these antiviruses and say that means everything's clean, and now we know it doesn't mean that at all. You need more layers of defense to pick up the stuff that gets past your antivirus. more people now. All right. All right, which one had the 6-byte timestamp? That's semantic. Really big, Norton. I don't know if it's still the big one, but it's a big one. Which one puts execution logs in the registry? That's Landesk, all right? Which one creates BUP files? That's Mcafee, all right? And which one of these is not suspicious? Yeah, installers that are run once and then discarded, that's normal. All the rest of these are pretty abnormal. Especially this one, in files with the same MD5 but different names and an application for recycle bin, those are very suspicious. All right. And so is an application without a version name. That means it can't be a commercial product. How would you update it? And 3, I don't know who JJ is, they'll have to tell me who they are if they want points. But the others, I know who they are. All right. All right, we can keep going. So then, of course, web servers, the two big ones being Apache and IIS. So web servers are servers. Your browser, when you go to a web page, sends an HTTP request or HTTPS, like GET to retrieve a page and POST to send up data like usernames and passwords, and the server responds with an HTTP response. If the old-fashioned HTTP, which is not used much anymore, runs on port 80, almost everybody's using HTTPS on port 443, so everything's encrypted. That's the modern standard. So you can run many websites on the same server, and it's quite a common activity, just to make it cheaper. And that means if one of those websites is compromised and the attacker gets to take over the operating system, they may affect them all. That's an issue. So the web server will have logs stored in plain text. It'll have the IP of the client, the URL requested, and the result. So you know what pages have been served up by that server. So searches you might want, or what requests were in a time frame or from an IP address or for a particular URL or containing a user agent string. And we did all these sort of things with Splunk. And we were looking at the various web attacks there. Good, yes, I see Judah giving me the real name, which I think we already know, but I'll make a note. That's good. It's nice to have it recorded. Good. All right. Anyway, so all right. So another big issue with web servers is you might have a lot of traffic, and so you cannot serve it all with one server, and you want to stay reliably up. So if one server goes down, you don't want your website to go down. So you have load balancing. You have typically a hardware load balancer in front, and then a pool of servers behind it, like 3 or 10 servers, and the load balancer will send one client to this server and another client to the next server and another client to the next server to make sure they're all serving clients, and that will both make it fault tolerant, so when one fails, there's still others to service them, and it'll of course have higher performance because each server will only have to serve a smaller number of clients. But this means that if you want to know what happened on one web server, like if an attacker manages to hack into a web server and compromise it, they're only going to get one of those web servers. And it's going to appear to have the same domain name and the same IP address in the logs, so you're going to need load balancer logs to figure out which server was the one used at that time, just like you do DHCP logs on the other end where the clients are. So that's an issue. Or, what's quite common, is you configure the load balancer to add an extra header field, like X forward or for. And by the way, if you use Cloudflare, which is a reverse proxy that stands in front of your server like a load balancer, it has software you can put on your server to add a header field for this, so you can track down which server you went to, both for instant response, and the main concern is not instant response. The main concern people have is tracking advertising. They need to know when a request made it to their server, when somebody clicked on a link. So anyway, they'll have extra header fields frequently indicating the actual server that you reached, which is not determined just by the domain name or IP address you put in. All right, so attackers typically hack into a web server by finding a vulnerability like PHP where they can upload a file and then they put up something like a web shell. This is a very common attack on WordPress and other PHP-based services. And so you'll get a file up there with an obfuscated PHP like this here. Now let me see if I can zoom in on it. Yeah, up here, let me make this bigger just so you can see it. There's the kind of stuff you'll see, and we saw this in the Splunk cast. Instead of having simple variable names, it defines everything. It makes this long string, and then it picks the letters out with numbers to like build a command. That's what you do to make it difficult to read. And there are plenty of ways to deobfuscate that. There are online deobfuscators, and you can just run it yourself and so on. But that's what you'll see when people are uploading malicious stuff to your server. Unfortunately, there are tools people use just to shrink their website, which sometimes look like obfuscation. But anyway, you see that kind of thing all the time on web server malware. All right, and so the web server itself has to run server software. Apache is the most common in small business and in my classes because we don't have money. And we just aren't focused on Microsoft servers very much. So this is what Linux shops typically run Apache. You can, in principle, run Apache on Windows, but I've never seen anybody do it. If you're using Windows, you typically use IIS, and you use Apache because you're using Linux. So it's got these configuration files in various different places that sort of overlap, and it's always pretty annoying to keep track of where you make the configurations. But it can do all sorts of advanced things. Its name, by the way, is because they said it was a bunch of patches. Patch this and patch that and patch that. It's a Linux-type joke, like almost all Linux names are. So it has log files, access and error in var log, where they ought to go. And so you'd have to add something to the configuration file to log the X forwarded for. You'd have to add this line. And then you'll see logs like this. There's a GET request. Here's the user agent. And there's the time and date. So that's the sort of thing you'll see logged there in the access log. All right. And so you put the actual web pages in a folder by default here, var www or var www.html, and you can change that. And software products like WordPress do change it. And you'll find these directives in the configuration file telling you where the actual web pages are stored. And the alternative, if you're a Microsoft shop, you use Microsoft IIS and you run it on Microsoft's web server, like Web Server 2019 or 2022. And so you configure it through the control panel, and everything is the settings are in an XML file. And so it looks like this. You have an IIS configuration file specifying the virtual directory path, which tells you where it is. And by default, it's on system drive C, inetpub, www root. And again, it's recommended for security purposes to redirect it to a different folder so attackers don't find it in the expected place. And here you tell it where you're going to put the log files, and so on. So the log files contain the date, and you can have advanced logging, puts files in a different directory. Logs are plain text, but they're encoded with UTF-8 because, remember, Microsoft does not use plain ASCII or ever. Almost everything is always using Microsoft's 16-bit Unicode, which is an old Unicode standard that Microsoft settled on long ago. So here's what you'll see. Date, time, source IP, client IP. I guess that's server IP and client IP, I think so. User agent, and other things like that. So here's a load of the server, and they've redacted some of the IP addresses here. Sort of thing you'll see. And we've seen these things are most useful when they're fed into a SIEM like Splunk. All right, and then you got your database servers. Of course, this is where you store all your records of transactions. So you have client connection logs that will have the IP address. One problem, of course, is that people often do not have logging on their database servers for performance. But for instant response, we would like to have logging. And so there'll be a bit of a struggle probably deciding that. You got error logs and query logs. Error logs are what everybody has. This tells you, but query logs people often don't enable, but that would give you a lot of useful information. The problem is they're big and they slow down the server. The data is stored in many files, sometimes a cluster of data servers. It can get very big. All right, and so be careful not to crash the database. That will make people very unhappy. We talked about this before. It's usually impractical to actually image the database drives and reconstruct the data. You have to use queries to work on it. So be careful when you're working on a database so you don't modify important things or cause a crash. All right, Microsoft SQL has a SQL Server, which is an expensive, powerful product, and they have a free version called SQL Server Express, which doesn't log client connections but only failed ones by default, which is very common for database software. And so here it logs an unsuccessful, then a successful connection attempt. So here's an error, login failed, and here's login succeeded. And both of them went into the error log, so that's nice. It records logins anyway. And it doesn't log queries by default, which would be very expensive because everybody is querying questions all the time. You can turn it on, but it will slow down your database server quite a lot, and most people are not willing to tolerate that. So you could make forensic images of the drive containing the database, but that would require taking down the database server, and if you have a large drive array, it would create a mess that you then have to work with. You can just copy the database files, ending in MDF or LDF. That's a much more practical thing to do, but you will have to take down a database to copy them. You could use SMSS to back up or export data. That's another option, but it is a live image, so it'll change some things, I think like timestamps and stuff. That's a live acquisition. And that SMSS is System Management Server, I think. Yeah, SQL Server Management Studio, that's what it is. All right. And your book is a little old on this. I think there's new versions of these products from Microsoft. All right, MySQL is the open source one. Now it's frequently called MariaDB. I think the original MySQL has been deprecated, and we're all supposed to be using MariaDB, which is essentially identical, at least as far as how it works. Yeah, the open source fork MariaDB is not owned by Oracle. So anyway, there's a configuration file, and you can tell it how much to log. Log errors. These are the logs you'll see. You tell it what to log. And your logs go in var log MySQL. Typically, you have only the error log on. You can turn on the other logs. And up to, I remember when I had a guy that hacked into one of my practice machines and did things I didn't think was possible. I couldn't catch him until I turned on Apache forensic logging. Was the way to do it, which records every request, which is not commonly on. That was for Apache. But in the same sense, you can turn on more logging in your SQL server if you're willing to slow it down to that extent. So here's user root connected to this IP address and executed this query, select star from CC data limit 1. So that looks like they're getting one credit card number, and this would be, but not a credit card number for one particular customer, so this looks suspicious. This looks like an attacker testing to see if they can find the credit card numbers. All right, so the MySQL data can store it in a lot of different ways. So the ideal way is to shut down your server and image the hard disk. If you want to do a live acquisition on a running system, which is probably far more likely, you could stop the service and copy the files, or back it up without stopping the service with a MySQL dump command, which would seem like the best thing to do under normal instant response. And then there's Oracle. There's Larry Ellison, the head of Oracle. This is used by big companies, insurance companies and such. It's very expensive. It's very complicated. We teach Oracle database administration here, and if you get that, you're supposed to be easy to get highly paid jobs. I don't know if that's still true, but that was a few years ago. That's what they said. Oracle database administrators were in high demand, and it's hard. But it works essentially the same as all the others, and has logs that logs the connections on by default, which is nice, and alerts. So you'll see a successful connection to an Oracle database is here. So it connects to testDB, and user is Bob, and here's the address. And it does not discriminate between success and failure, which is rude. But anyway, at least you get a record of who's connecting to your database. All right. So let's try the last Kahoot, which is here. They use that JavaScript to animate the button, so I can't click it. This whole thing is sort of sloppily made website. You can tell they don't have much money. But it works. Give it a try. All right, free open source software. Apache, everybody knows that. That's good. The up-and-coming contender is the Russian one. Can't remember the name of it, the Russian web server that's competing with Apache. Used to be used to run botnets. It's much faster. A stripped-down version of Apache. The name will come to me. Anyway, it's now quite popular. Anyway. Which item conceals client IP addresses from server logs? I think it actually conceals server IP addresses more. That question is not phrased as well as it should be. But that's load balancers, of course. All right. I think that should say server IP addresses from some logs. Nginx, that's it, thank you. Nginx is the alternative to Apache that's really coming up. It's much faster. They removed the difficult features from Apache. All right. All right, which one is free but not open source? SQL Server Express. Microsoft used to have a bunch of these Express things like Outlook Express. I don't know if they're still doing it that way. All right, which one is a tool used to manage a database server? SSMS. That's it. SQL Server Management System or something like that. All right. All right. Which one logs connections by default? That's Oracle. Good. All right. who that is. I guess they'll have to tell me if they care. I know who that is. All right. All right, let me stop this recording.